or nobody. So the product rule for derivatives is u prime v plus u v prime. So if we were to integrate both sides, this is kind of not being completely formal. If we integrate both sides, but basically an integral and a derivative cancel each other out. In the sense of integration, instead of calling it u prime, let's call that du. So let's call this v du. And this one u dv. And let's solve this for u dv. We leave u dv alone. Move that to the other side. We get this. And this is what we call integration by parts. If we have a function that we want to integrate product, then often we can think of it as one of these pieces being u, one of these pieces being dv. So to get what that is equal to, that integral would be equivalent to doing u times v minus the integral of v du. So we have to be clever with what we pick for which piece, whether we call x dx dv or whether we call cosine x dx dv. So we need basically four things. We need u, du, v, and dv. So we want to pick the one for u that when we take its derivative is going to get simpler. For example, here we can pick the x to be u. And when we take its derivative, then that gets even smaller. What's the derivative of x? Dx. So we're going to call this part dv.
So whatever you don't call it,
Then the rest of it will be dv. Right. So we want to work backwards from dv to get v. So if we were to integrate both sides, what's the integral of cosine? Sine. The derivative of sine is cosine, so the integral of cosine is sine. So if we take that and plug it in, let's see if I can drag some of this stuff up here. So with what we pick to be u and dv, then filling in our formula, we have u times v minus the integral of v du. Notice that integral has du in it. That's why we picked u to be x, so that when we took the derivative, it got smaller. It got something more simple. So in this case, we don't even have an x anymore in that integration. We know how to do that integral. Yes, I mean, basically, this is u, this is dv, so this is the answer to our integration problem. So we're not done. The answer to our integral, notice, still has an integral in it. So we need to integrate this. So we've got x sine x minus, what's the integral of sine? negative cosine. And it's an indefinite integral, so we need a plus c. So x sine x plus cosine x plus c is our integral. And most of these are going to have something similar to this, where we have two factors. One factor that when you take its derivative, it's going to get to like a lower degree, or it's going to get simpler. And then the other one is going to be something that we know how to integrate. Now, there are several different variations, and we'll look at several different ones. Let's do a similar one. If we wanted to, we could take the derivative of that to check to see if that really gives us, if that really is correct. Let's do that just real quickly for this one. If we take the derivative of this to check to see if that's our answer, the derivative of this, we use the product rule. So the derivative of x times sine plus x times the derivative of sine plus the derivative of cosine. And then the derivative of the constant is 0. So what happened to our sines? They cancel. And yeah, so what we got for our answer, that is the function whose derivative is x cosine x. So that's the thing that makes integration tricky, is that there are times where, okay, this is our answer, but there are pieces in that when we take the derivative cancel out. So we can't really account for all of that in just our u. So we have to have something else. And that something else in this case is this integration by parts. Let's do this one. As it stands, we can't integrate that by previous method because since we have e to a power, we would normally pick that exponent to be u. But if we pick that to be u, this other stuff is obviously not du. If we pick this to be u, du would be 2x. Well, we've got an e to the x. That doesn't work. If we pick this whole thing to be u, then du is e to the x. Well, we've got an x squared. So anything we pick for u is not going to give us one of our formulas that we already have. So let's try to use integration by parts. And it's basically going to take it and kind of rewrite it into an integral that we might know how to do. Yeah, so let's let u be x squared, dv be e to the x dx, which is good because what's the integral of e to the x? E to the x, and what's du? 2x dx. So our integral we can rewrite as x squared e to the x minus the integral of e to the x times 2x dx. Of course, we can pull that 2 out front. Can we integrate that one? Is there something that we could pick for you to integrate that? If we pick that to be u, then du would just be dx. So we would have e to the u, but then we would have u du. So we still can't integrate that. can do it another time. Yeah. So we just repeat. We have our minus 2 out front. So this time u would be x dv e to the x dx. So the integral of e to the x dx, that's still e to the x. And what does du come? Yeah, 1 dx. So if that's u dv, then the integral of u dv becomes u times v minus the integral of v du. Can we do that integral? Yes. That integral we can do. So I'm going to leave the minus 2 out front for now. And what is that integral? What does that give us? E to the x. We can get rid of our bracket by distributing that negative 2. If we want to, we could factor out an e to the x. X squared minus 2x. Oh, hold on just a second. We left something out that's going to make it. What did we leave out? We integrated here. Plus c. So when we distribute that negative 2, we end up with a negative 2c, but isn't 2c just a constant? Yeah, 2 times c, that's still a constant, so we could call that, let's call that plus c, capital. Yeah. Yeah. Because this was the integral that we were doing the second time. So because the first time du was 2x dx. So u times v minus v du. So we added e to the x, 2x dx. So we just pulled that 2 out front. So then we need to do that integral. That integral we couldn't do, so we had to do that by parts. So I just left the 2 out front, and then we did that integral by parts, and we called this u and that dv. So with the integration by parts, we work it down until we get to something that, hey, we can finally do this integral. We know how to do that. Let's, yeah, since I left constant out, there's, I mean, we could take, I guess technically factor e to the x out of the first 3. What really makes a difference? So if we were to take that derivative, it should end up giving us x squared. All right, let's see. Let's do this one. Now, neither one of these really get simpler when you take the derivative of. So you might be able to do this more than one way. But normally what you do is you let u be this part and dv be this part. Since the integral just gives you a set. So let's call u cosine dv e to the x dx. So why wouldn't that make v? E to the x, why would that make du? Negative sine x dx. So the integral of e to the x cosine x dx is u times v minus the integral of v du. If we want to, we can pull that negative out front. Take this negative out front. That'll make that a plus to the integral of e to the x sine x. Now, okay, we haven't got anywhere yet. We still can't integrate that, but something interesting is going to happen if we repeat this. Let's do this again. Yeah, exactly. Let's let u be our sine, our dv be e to the x dx. So that part is dv, and that part is u. So what's v and what's du? Yeah, the derivative of sine is cosine. Yeah, that's going to get us back where we started, which normally is a problem. But let's see. So this gives us u times v minus the integral of v du so that's equal to our original integral. Okay. So wages. We took one integral. This is what we're trying to find the answer of. And after doing integration by parts, we picked up two extra things, and we still have that integral in the problem. So let's do this. Add it to both sides. So that gets rid of the integral on the right side. So our right side, we have cosine x times e to the x plus sine x times e to the x. What does that give us on the right side? Two integrals of e to the x cosine x dx. How do we get what we were looking for? We were looking for that. How do we get that by itself? Divide by 2. So the integral of e to the x cosine x dx is half of e to the x cosine x plus e to the x sine x. So that comes up somewhat frequently. But just keep in mind that, okay, when you've got cosine, if you do that twice, it's just going to work its way back. When you take the derivative of cosine, you're going to get a something sine. When you take the derivative again, it's going to get you back to where you started. So you end up with that integral twice. Well, fortunately, once we move that over, we don't have an integral on this side. So if we want to get that, just divide by 2, and that gives us our function. On page 520, they kind of give a list of, okay, if you've got integrals of certain forms, what to pick. If we've got integrals with x to a power, e to some power, or x to a power, sine or cosine to a power. I said to a power, sine or cosine of something. Then we always want to pick our u to be the part that when we take the derivative, it's going to get smaller. And then our dv to be the other part. So if it's one with the e, or if it's one with the sine or cosine. So if you do have a power in there, x to a power, that's going to be your u. Sometimes we'll have okay, that's cool. Sometimes we'll have one that's something like this, or something like this, or like this. Well, we have to be careful then. Normally when we have x to a power, that's what we pick for u. But notice, in this case, if we pick that for u, then that would have to be dv. We don't have a formula to integrate natural log. We have a formula to take the derivative of natural log, but we don't have a formula to integrate natural log. Same thing with arc sine, arc tangent. We can't let that be dv because we don't know how to integrate that. We don't know how to integrate that. So let's work one. Let's work this. We actually have x to the 0. We don't have an x here. So we can't pick that part to be dv since we can't integrate it. So we're going to pick that part to be u. So in this case, dv is just what? dx. Trace, I'm recording this, so when I post it, you can go back and watch the first part of it. But we're doing 8.2, which is great. The formula is if you have the integral of u, but you have a different dv, instead of having the same variable here, that becomes uv minus the integral of v du. And I showed them earlier, I may have erased this already, that comes from the product rule. I did erase it. If you take the derivative of a product, the derivative of a product is u prime v plus uv prime. And we've discussed, well, we don't really have a product rule for integration. If we integrate both sides here, an integral and a derivative undo each other, so u times v is the integral u prime. In terms of an integral, we can think of that, instead of calling it u prime, call it du. V prime, instead of calling it v prime, we can call it dv. So if we subtract v du from both sides, then the integral of u dv is u times v minus the integral of v du. And it's just a way of kind of picking apart certain pieces of our integral and writing it into something else that we know how to integrate. All right. So if dv is dx, what does that make v? X. You think of that as 1 dx. If you integrate 1 dx, you get x. All right. And the derivative of arc cosine, if you flip back through your formulas, if we have arc cosine u, the derivative of that is negative u prime over the square root of 1 minus u squared. So in our case, our u is x, so our derivative of arc cosine is minus u prime, so the derivative of x is 1, over the square root of 1 minus u squared, so x squared. So that gives us our u, v, du, and dv. So if that's u and that's dv, then the integral of dv integrates into u times v minus the integral of v du. So that's the integral of v du. You'll see where all that came from. This is our u. We just used our formula to get du. That's dv, then the integral of that is v. So when we plug into our integration by parts formula, if that's u and dv, then u times v minus the integral of v times du. Let's rewrite that just a touch. Let's put this x out front so it doesn't get mixed up. Let's pull this negative here out front. Make two negatives make a positive. Let's put that x on top. Dx.
Okay, arc cosine x. That's u equals arc cosine u, right? And then when you go to du, you have negative u prime. So how are you?
Okay, so it's a different u. So for taking the derivative, forget this u. So the formula is to take the derivative of arc cosine u. So for getting this, our u is x. So it's minus u prime, so minus the derivative of this is 1 over the square root of 1 minus, if this is u squared is that squared. That's easy to get confused because it's two different u's. Does that make sense? All right. this is something we can do. How do we integrate this? U be 1 minus x squared. So what would that make du? Negative 2x dx. So that being u, then the rest of that needs to be du. So what's the only thing we're missing? Negative 2. If I put a negative 2 there, we need a negative 1/2 out there. So our integral is x arc cosine x minus half of whatever we get when we do this integral. That's du. It's du over the square root of u. What's another way of writing du over the square root of u? U to the negative 1/2. Keep in mind we're resetting our u. For this integral, our u is 1 minus x. Well, what rule do we use to integrate that? Yeah, that's just our power rule. So our 1/2 is out front. That's u to the 1 greater power. 1 more than that is 1/2 over 1/2 plus c. Well, we got a 1/2 on top and a 1/2 on bottom. What happened to those? Those cancel. So we have x times arc cosine x minus u to the 1/2, so the square root of, what is this u? That u is 1 minus x squared. So that's our integral. So that's the that smoke I see coming out. So this is just another tool to add into the toolbox. When we did 8.1 the other day, we had a list of like 5 different things to try. Okay, if we look at it and we can't immediately pull out, hey, let this be u, and then du is the rest of it. Well, if that doesn't work, then we had a list of things. Okay, if it's an improper fraction, divide it. If you have more than one term on top, write each term over the denominator, and several different tricks. Quote unquote trick to put in your toolbox. If you've got one that those other things don't really apply to, and we don't have an integration formula for this, try to integrate by parts. And on 520, there's pretty much a list of things that, hey, these are ones that you might try to use for what to pick for your u and dv in integrating by parts. All right. Trying to see if there are any other specific ones of those I want to work. I don't think so at the moment. All right. So I'll give you a variety of those, let you work on some of those, and then we'll take questions next time.